Hi, Assalamualaikum. So today we're going to look for the Boyle's law experiment, which is this Boyle's law experiment, which is has been developed by Robert Boyle, which he had studied on the relation of the pressure and the volume with the V in the confined gas at the constant temperature. So according to the Boyle's law, has stated that for a mixed mass of the ideal gas at a fixed temperature, the product of pressure and volume is a constant. So um, yeah, so Boyle's law, which is can be summarized as the PV P times V is equal to constant when the temperature is held at the constant, uh, or that is unchanged of the temperature. So when the temperature is maintained at the constant, so this condition is called as the isothermic conditions. Okay, and then comes Gay-Lussac law. From this Gay-Lussac law, it has stated that a fixed quantity of gas is contained at a constant volume. The pressure is proportional at the absolute temperature. So when the volume is maintained or the volume is held at the constant conditions, so the pressure um, uh, is proportionate to the temperature. So what we have here is that P over T is equal to constant. Okay, so with these conditions, okay, so before that, when the V is maintained as the constant, so this is we known as the isochoric conditions. Okay, when the both law is combined, which is the Gay-Lussac's law and the Boyle's law is combined, so then we can get the ideal gas equation of state. Okay, so where PV over T is equal to P1 V1 over T1 is equal to P2 V2 over T2. So from this condition, it can be expressed that for the development of ideal gas equation of ideal gas equation of state. Okay, ideal gas equation of state, where PV uh, PV over PV is equal to MRT. So, or it can be stated as the PV over T is equal to R. Okay, so where R is the gas constant, which is equal to the universal gas constant divided by the molar mass. Okay, and then for the Boyle's law demonstration, you can refer to the YouTube video that has been provided. So through this experimentation work, you are going to simulate 4 conditions, which is the heating at the constant volume. This is heating at the constant volume, or isochoric heating, and then you going to do the isochoric cooling, which is the cooling process when the volume is maintained, and then isothermic compression, where the pressure has been increased while maintaining the temperature, and then isothermic expansion, where the temperature is maintained at the same temperature. There will be a changes of the volume, but at the and as well with the with the changes of the or drop of the pressure. Okay, and then the result for the heating and cooling you're going to put in here, and then for the isothermic compression and expansion is available in here. Okay, so I think that's all for the theoretical perspective for the Boyle's law. And then I leave you guys to follow on the YouTube for the experimental work. Okay, so thank you very much.